Buenas. No fui yo. No. No le cae. No. They are gossiping. It's okay. That's for the they are gossiping for the next semester. It's okay. That's for the
¿Qué? No, que yo sepa. Pues por ahora, no.
O sea,
Sí, exacto. Más probable es que no.
So, instead of going to be playing around with some just simple SDH like relations, mostly in 2 dimensions, so it's runs quickly. The material this time is not in the same repository or nomenclature, so you can either copy whatever is so that link at the top or that QR code is just this presentation so that you have the material on your machine so you don't have to, well, you can move at your own speed with instructions that will follow. But I'll still walk through the first 2 steps now so that we are all on the same page. And I'll put this back afterwards. Okay. So that's the last slide of this morning. So I was to say, what we want to do is to use the SPH part of the Swift code that we haven't done the last 2 days already. Today, we're not going to do any gravity simulation. We're going to just use the hydrodynamics part. And as I mentioned, we're going to do 2 things. One is run a standard test so we can understand a bit how these different components we talked about this morning work together. And then the second one, we're going to play a bit with taking an image and turning it into small black. Yeah. I'll put it back afterwards. Okay, so you already should same business. Only thing today is that instead of the code was configured by default, it's running always in 3 dimensions. But we're going to do some 2-dimension simulation today just because it's easier and faster. It's only visualized. So you need just to, when you ran configure yesterday, you probably didn't have any of the configures, which is in default, or maybe some of the enable this friend-to-friend thing to calculate ADOS. But today, you just need to add with hydro dimension equal 2, which converts the code to only consider x and y coordinates instead of doing 2 and 3. Also means you can't do gravity anymore. Gravity really is a problem for another life. And then once you're in the code, you may have seen that there is a directory called. And so in that directory, there are many small simulations that you can run. Some small and some really big ones that you can run with the Swift code. In particular, there's a directory called hydro tests, and we can play around today with this one example called the salt shock I mentioned this morning. These are sort of long tubes where it can test. Yes,
Teacher, can you show the link again?
yes, I'll show it again in a minute.
Thank you.
And so that idea would be we can play around with this test, and then if you want some more, so that you lead to something like that, and we can play around the parameter file and play with the resolution, the time step, or a few things to see what comes out. And then there are, I'll switch back to the link in a second. But there are a few other examples that you might find interesting. Set of labs is a classic problem. If you go back to, this is just taking, so it's like a spherical explosion. So you have very hot region center and you have a really big bubble expanding. This has different application. One is supernova, so you have a star exploding, injecting a lot of energy. Now, Sedoff and Taylor who derive the solution. Analytically, you can derive it for supernova. They derive it because they were interested in testing the amount of energy coming out of the nuclear explosion. So that's the same solution, which has good sides and bad sides to what you can do with your physics equations. And then the other one, which could be interesting, is the one I showed this morning with all of the vortices. This is the Kelvin-Hadron system. So you can run these. So I'm going to go back to the link. So you can try to get started with this, and maybe in 20 minutes or so, once you have gotten started, you can play around with the other parts of the tutorial. That's right. Slides. That's the slide. Does it work? Try it before.
Sí, ¿no crees?
But it's exactly that. It doesn't work, you can try to use the whole thing.
Que ya viene. ¿Sabes que Marta cómo va a venir para esto? ¿A qué hora es? Ya. Con todo esto. Hoy ya llegó. No llegó.
La biblioteca de Buenos Aires. Al lado de la calle.
Sí. ¿Alguna te preparado? Estamos bien cerrados.
The thing is, the link is working, but the internet connection.
That I can't do much about. No, es muy pequeño. Everything working with the link? All good?
Te mando el del niño con el
No son niños.
Me pregunta, te mando ciclos de las bulas desde que nos conocimos. Y dijiste, es un niño. Te dije, no, es un niño, es una persona que sufrió de sí, pero te mando.
En el mismo plazo.
Yo me acuerdo que en la última sesión de presentación, sí, compartía una de las bulas. Pues era literalmente la cara de la
Ay, sabemos porque fue bailar. Muchas cosas. Bueno, o para pensar. Lo que te dije.
Slowly. Okay. Well, the instructions are on screen as well in the meantime.
¿Y qué pasó al final con el... ¿Leíste el blog?
That's why I sent you the link to the start.
So we don't have to work with the GitHub.
You don't have to work with the GitHub.
Okay, so.
You don't have to work with the GitHub. So, so on Monday, did you run the code or did you just run the business practice? Did you run the simulation? So you run the particle physics, you run the simulation. Okay, so you only run the 3D version. You didn't run the simulation. So then you look at what you did on Monday. In the script of Monday, it goes to instruction how to download the code, the simulation code, not the Jupyter code. The simulation code, and how to install it.
Are you serious?
Yes.
Oh.
And especially if you go to the main page, there's a big wiki with the instructions.
Yeah.
So if you follow that,
This is the GitHub thing. There you go.
I can tell which bit is needed.
Yeah, good.
Everything is interesting.
Yeah.
But, so this bit here, that how to install and run Swift code, which is the connection code we're using.
Ya entendí.
So that's bit. So today we also using that code. Also. So the Jupyter things on the Python. If you have to run this connection, you look at the results using Python from Jupyter to look at the results. So that's what we have done. But you haven't run the simulation. That piece of code, this is what it is, and you get everything more. It's also what we used in the session yesterday. So that's why, again, I know you were not here yesterday.
Yeah, it was absent. Yesterday was not there.
So it would be, if you have the, let's say, that part, yesterday, you would use that same. Oh, you did this yesterday, or, yes.
Oh.
Thank you very much. Yes.
Sorry, part example is
Yep. From the where are you in the Swift? Yes, you are in the Swift directory. Yes, from here. There should be an examples directory. Yep.
and
Especially if it's third. That's the one I showed you. I see some results at the back. Everything working. Anybody stuck with something?
I'm stuck.
You're stuck.
Yeah.
Let's try to save it.
Yeah.
Yes. Yes. Close.
And then when I do this, then I do this thing.
No, these are libraries that we have installed. Yeah. Maybe we have this installed. I don't know which one you're missing. These are the ones that we are usually missing. No, the ones. We already have this. I don't think no, it was a place.
I think that this recipe.
Eso es raro, pero. Este hermano está saliendo. Pero que ya no.
Do you need a chair? You need a chair?
Esta vez la explosión está en vivo, siéntense.
You're saying for logistics.
Estamos con.
But yesterday was working here. Yeah. But I need you. You do something to computers and computers don't like you, Susana. Yeah, that's so if you're missing the library, then I don't have any permission.
Ay, a mí me pasó, o sea, que eso es por el internet. Ok. No, yo me fui al baño y ya lo había.
Yeah.
Y dice 22 minutos.
So you should get the money. So the run, yeah.
Hay tiempo de volver a instalar suites.
This is the so okay, right. The run, if you look into the run.sh, it does multiple things. First, it creates initial conditions, then it runs the code, and then it runs a script that makes the process. So if you do less on run.sh, LSS, or you open it, the file run.sh. No, open
¿Qué pasa? ¿Por qué no viniste?
Me quedé haciendo
¿Me quieres sacar la de ese sentecito ese?
So it does three things. One is that it makes this initial condition, then it runs the code, and then it plots the solution. So all of the writing is pretty good. So it was like yesterday, but all of the steps, and then directly run it. But at the end of this process, you get a snapshot like yesterday. You
cargo al 20% y digo, faltan 22 minutos.
plots the result directly.
Y yo,
They didn't save the figure.
esperar 22 minutos. 27, subió.
Or package, yes.
Pero ese me da igual, solo de la clase de va a funcionar.
Yo vi esa cosa y yo dije, esperar
The ICs are in 2D, and you try to run it. You should have configured with higher dimension.
Pero además, muy difícil que no se pueda robar esta letra. Intenta robarte el caldero.
Los de atrás, pero
Pero no necesito el caldero.
yo tengo un cable que tiene ese cable.
We had a problem trying to
Yo no trae el control porque ayer instalé todo en tu. ¿Dónde están? Pues mira, ahí se vamos a ver.
Ey, te presto un cable.
Pero es que igual el mío no.
No tiene.
No.
Es un feo tampoco.
Y que le puedes hacer así, eso igual. Sí. Solo que cada vez me dice que se demora más. Voy a practicarlo de mi multilingua mientras tanto. Encaremos tu este momento.
Sí.
Sí, tiene nombre.
Sí, no tiene nada. Se necesitan estos días.
Seguro que no le dijo antes de hacer las cosas. Nico. El de computadora. Sí, él está usando un poco. Vamos. Baila.
Okay, so I've seen some of you already done this far, running some of the examples, running some of the simulations. So I'm gonna, you have the script, you can go at your own speed, right? Of course, I'm still gonna keep going a bit and see what comes next. So, okay, so that was a bit of warming up exercise, running something. We've already done that yesterday, so you can remember what we did. Same thing. And you will see that the code, the script, and if you look at the run script, plus printing, it makes initial conditions, it runs the simulation code, and it also calls the Python script that makes that blocks the solution. So that would be the solution file of that. But if you remember yesterday, the code was generating some sort of HTML5 file, which contains all the article information. It's the same today, there's still this HTML5 file, but there's also a Python script already included that directly makes the figure that forms at the end. But this can be changed, or you can look at the particle itself if you want it, like in this. Okay. And there are the two other examples here right now. The other thing we want to do today is the one I mentioned at the end this morning. We can try to do something a bit more fun, try out something a bit different. And I'm going to help you a lot less. So the simulation part, we're going to run the code, but I'm not going to give you the piece of Python around, because I think from what I've seen this week, you should be able to do some of the coding around it. And well, I have a solution, and you can also ask for help, but the goal is that you try to do a bit more yourself. And so what we want to do, we're going to take a square image of your choice. Works better if it only works if it's square. Actually, the code is not going to be very happy if it's not a square. What we're going to do is that we're going to turn whatever image you have into a particle distribution. So we're going to first turn it into a density field, so we can make it say, if I took this image and make it black and white, then I can say where it's very dark, it's very dense, and when it's very light, it's very low density. Right? So I have a density field that will be like my image in black and white. And once I have that, once I have for every, if I make pixels in my image, then I know in which pixel how many particles I need to start for my simulation. Okay? So for the steps, one is take an image, two is turn it into a grid of pixels, right? And I would recommend that we're going to use 256 pixels by 2056. So otherwise, it's a bit too many. This written down further down. And then once we have this, we turn it into either a black and white image, or I think what image people call posterize the image, so it has only a finite discrete set of level. And then once we have that image in that format, we can think of it as it was an image. We can think of it as a 2D array, and in each pixel is just a number, which is the density. And what we're going to do from there is that we're going to just put, if the density says here is 5, I'm going to put 5 particles on that pixel. Maybe just randomly within a pixel, or in a grid within a pixel. That doesn't make much of a difference. Just if the density is 5, you put 5 particles on a pixel. Density is 23, we put 23 particles on a pixel. And as a consequence, we're going to create a density field of particles that has the density we want. Right? If I now make a projection of my particles, there will be regions with a lot of particles that are very dense, and regions where very few particles that are low density. So it should be looking like my starting image. And once I have all of my particles, well, I can feed them into the code and just run the simulation and see what happens. Okay, so that's the goal. I'm not going to give you much code to do this. The goal is that you try to do, so running the code, I'll give you the parameter file, but making the initial condition, making the particle distribution for you to do. And if we don't, I'll give you a solution later anyway, if we don't make progress. So the other thing you can do is to look at the notes. There is a small GitHub you can load. The solution is not in there, so don't look around. It's not hidden in there. But in there you will have a run script for the simulation and a parameter file for the simulation, which we're going to use further down the line. But once we are ready, once we've made our particles, we will use these files. And there's also a small script to make a movie from all of the images. But I guess you already made movies yesterday from the results. You already know how to do this. You don't necessarily need to run that script. You can do it yourself with whatever movie, GIF, turning tool you like to use. Okay? So the first step for today is we're going to do something like that. I'm only going to be giving you some small hints. So load an image. Right? If you do this in Python, I think you can install it via Conda or via Clip or whatever. I recommend using the Python image library. You can also do it directly in Matplotlib. That also works. This is just a lot easier because it has standard function names. So what I've done is I've taken my image from before, I've loaded it, and then I turned it into a grayscale because I only want black and white, so black, gray, white, right? So they have different levels. And then I've posterized it, which means I have made discrete levels. And then I can just look at it, and that should be my result. Something like that for the image I chose, just pick whatever you want. And I'm going to stop here for instruction and give you maybe come back in maybe 15 minutes to the next step. But the next step will be once we have this grid, we're going to make particles. Good. You need the link? I posted the link at the start. Yes?
Yeah. Están ahorita. Estás en sesión.
Yo la jugué. Tutorial.
Sorry, Matthew, after we run, for example, an example code that produce the graphs instead, or we have to run another code to obtain the graphs of the.
Oh, you mean in the first part? Oh, what do you mean?
Yeah, sorry. Give me a second.
Which part of the instruction are you on?
There. After we run this,
Yes.
we obtain immediately.
Yes,
this
so
graph.
the script, the run script here has three.
Includes the graphs.
Yeah, it includes the floating script. So it's already directly. But if you want to make it so refer to the code, writes out snapshot like this, it's like extension 5 value or properties of the particles. That's always the case. But then there's a small Python script in there called the plot solution that takes this and makes the graph of the result.
Matthew.
Yes.
It didn't work because there is an archive that doesn't exist.
An archive that doesn't exist.
A file. Thank you. Gracias. No problem. Ay, no tengo la cuenta.
Sorry, I should have come to the other side. I think it's loading something. I think it's just the internet thing if it's slow. Probably.
But I was doing wrong.
Yeah, so the run.sh does different things. Like the first thing it does is loading this file. Oh, it's working now, which is very, very slow.
But this one is get lost.
Yes, so the run.sh, in there are 4 or 5 different instructions. The first one is to get the glass, then the second one is making the initial condition, then it's running the code, and then it's plotting this. Let me, so if I do that, you can see first we get this file, then we construct the initial condition, then we run the code, and then we plot the solution. So all I've done here is just call directly that, just to test because that's what I wanted to test. But I could have done run, we also want just loading the file. Make sense? Yes.
La excepción de la banda de paz la tenemos que hacer cada vez que repasamos la
Wherever you want. You go wherever you want, and then once you're ready with your initial conditions, then you go with this and whatever the declaration comes up. I'm not giving you the whole code. Sorry? Yes? Yes. 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 Cool. Is this going to happen again? I saved it yesterday. Oh, yes, because yesterday you ran the simulation yesterday, right? So it was working, but I added it to the. Okay, so if it doesn't work today, you know where to find that line. It's probably going to be faster to find it there than me remembering.
La que era también.
Honda, que busca Honda.
No, entonces no.
Okay, that's almost done.
So we have to run, and then we have to get run.
No, you don't have to, because run does runs all of these other things.
So this was an error because we lost the connection.
Yes. It's almost done. So now, wait, I think it's too big. So now what do we have here? Okay, we have two of them. Okay, but it did work the first time. Yes. Okay, so if I do. But that's the problem. It has exactly the problem from yesterday.
Honda.
It's this Honda thing. So if you figure out that line, yeah, it was section 2.
Well, if I have mine.
Nice.
That one should be working. Also for you.
¿Dónde está? En la aplicación.
Nope.
Nope.
Okay, yours was different, so that's really cool.
Y acá el FTW. Mira que el quiere decir, por eso que yo puse que lo había instalado todo.
Working. Okay, so I guess you have to do this every time you have
That was really fast.
very small section. It's only 2 pieces.
Oh, no.
That should be fine.
Warnings.
Only warnings.
Ya corre como la de ayer, sacando pasos.
Sí, sino que yo estaba corriendo otra. Yo estaba corriendo. O sea, las próximas segundos.
Mira, entonces ahorita nos está corriendo con ese, pues, con una barra horizontal y nos da cuenta. Porque lo pero no me imagino.
Ah, no, sí, es el primero. Ah,
What?
Por eso era que yo decía que
Sí, pero no estaba.
si quieres prueba, ahí está como
After events, we doesn't show the plots.
What do you mean? I've created a plot. It's probably ls in the directory. ls. There's a file here. That's just the plot.
Okay. No vas a crecer más.
no sé. Pues me puedo aplanar más. Sí me puedo aplanar más.
Está.
Me siento y me aplano. No puedo correr.
Sorry, I should have added it. No, that's me. I didn't add it today. So, we did it because the funds are go back.
Funciona.
Ahora que sí se supera funcionar.
Literal.
¿Y dónde miro por eso?
Eso te crea un archivo PNG en la carpeta de la simulación.
Here, the image probably has black and white. We'll have maybe 6, black 0, white 16 million something. That's way too many levels. Okay. So buffer just makes it go more discrete levels. You can see here has sky, right? It has very few levels. So otherwise, if we make it 1,000 or something, it's way too easy. Yes. Yeah.
Pero ahí sí, nos había dicho, porque mira que todo
Oh, okay, so it's trying to load.
Que se llama Mark. ¿Por qué pones las reinas del coso de... Muéstrame, pero no. ¿Dónde lo corriste? Ya lo corriste, ¿verdad? ¿Y dónde está? Déjame la finalidad. O sea, corrió todo bien. Porque mira cuando corres. Terminamos los pasos. Ya es todo. Solo. Todo.
Pues sí, pues.
Mucho más rápido. Tú tienes instalado Conda, ¿verdad? Sí. Cuando uno tiene Conda, Conda no funciona. Entonces debe separar en la carpeta madre Swift. Y ya te digo que ponete en la carpeta madre Swift. Solo en Swift.
It has one support. Okay.
All the way to the end.
No, this one is.
Oh, it's getting handbook.
Que le dé en mayúsculas. Ya lo tiene.
Isn't that the one we tried before?
No.
Oh, you were in the seventh class. Oh, no, okay. I mean, it's the same file, it's a copy. So the get class loads the file. I forgot the name of this called, glass layer something. You copy it from one and then or you can wait until it goes. But it's still, I think it was working. Right? It has worked. Because it's loading it the second time. Yes, you already have it. This is so short. So you already have it. You're loading it the second time.
Lo que hace es como poner en el, o sea, lo que yo entiendo, tampoco sepa lo que hace, poner las librerías que están en la cuenta directamente.
Yes, it's going to have the same problem.
Ya lo pusiste. Pues ahora vas otra vez a la carpeta.
One is I didn't completely finish the load, so I don't know what happened. Something broken in the code. And you have the same issue here. Every time you copy you turn the conda thing. Or we can put it in your background and see that it's loaded forever.
Okay, where?
That's right. So if you load the line, this conda line that we need. Yeah, so if you copy that, okay, now if you go into your home space,
Nosotros los escriben. Ayer nos dijo cómo vamos.
there should be a file here called .bashrc. Hidden in constitution. If you open it with
Al final, esto lo que hay.
scroll up, yeah, this file here. Yeah, so if you open that file with gedit or anything you can define. Yeah. Right, and you go to the bottom of it, and you add. This thing, every time you open a terminal, all of these things get run. Apparently there are things where you combat that happen and a few other things. So now if you open a new terminal, that line will be executed and it will always be.
So I don't have to how long.
Well, you use this one because you have it loaded.
Está
So
compilando.
if you close that terminal and you reopen it, now it should be loaded. Magic.
Es que yo te dije, te puedes ir a no sé si está bien. Sí, ese comentario, pues es un comentario que ya está bien.
Eso es lo único que sale, eso es lo único que hay. What we need to convert this certain number of integers. Maybe you can take the but inside the 2 million bucks, maybe you can 15 levels.
Yeah, you don't
Pero ya trabajaba con él aquí en la parte. Yo entraba en usuario y en el usuario ponía y aquí lo
Ya te presentaste.
y ahora yo no sé, piensan yo que está localizado
What posterize mean? If you use ITIL, you just go posterize, and if you do it by hand, you just whatever by hand you want.
Además, que despertada y eso cuenta como premios de la no tengo excusas de hacer nada. Pero igual no quiero pensar. Porque sé que no está llegando.
Pero ahí está haciendo.
¿Qué le faltaría?
The number part is not set. Number part is
No, pero
A ver, ¿qué está haciendo? Ya pudiste ya pudiste.
Pero otro. Pues yo la verdad estoy esperando
I mean, we used it yesterday. Yes. So I don't. So what did you work yesterday?
No,
So if you work yesterday, what have you started again? At least it was in some of the bits of the end of the tutorial, but I don't know, maybe you didn't go to the end. Okay. Then I don't know. Okay, it looks like
No, eso me lo escribí. Por eso la ahorita lo pasé. No me pierdo.
Bueno, sale de hoy y arrancó la pelea corriendo desde
It's not required exact person.
that's probably the latest version.
Mejor dicho, hay que hacer cualquier librería como el fórmula que paga básico, o sea, primero instalar la Swift FB, trata y ya después.
So then, of course, the find the package. Here, it's got here. The next one. Okay, let's see what number is done and try That's the problem. Some computers
¿Qué pasó?
Ya ahí volvió, ya.
Control C. Si no, la verdad esto te lo paso.
What is exactly? Oh, so you haven't installed the key package.
Ahora ya está instalado. Para ver cuál es el instalado.
Errores.
It's very strange. Like, I think they run the same script as others.
Ahora sí, la carpeta
Ese tipo de cosas no sé si reír. Ahora que preguntas a Mateo.
I got this error and I don't know what isn't working.
Let's go back to the first error. Can you make the screen bigger? Okay, so
Wait.
no, it's fine. It's okay like that. You just mean full screen. I don't need it bigger. Can you scroll back up a tiny bit? Okay. So, hey guys. Okay, so the first, it's somehow they didn't do the first. Can you do? Okay. The script is loading a file from the internet, and somehow that went wrong, and then the rest of the script just does something stupid. So what do we have here? We should have everything. Okay, so let's try again. What if I do? Okay, see? Okay, so one of the files is not good. This one is not happy with this one. It says something here and then it crashes. So if I remove this one, But did you run the other example? No, you haven't run any examples so far. Okay, so let's do that. Just running the get thing and see whether it doesn't time. Hopefully, it doesn't time out this time.
What is the get file?
So to start a simulation, we need the sort of basic position of the particles, and what we do here is that this is sort of a randomized distribution of particles.
Okay.
In the Kelvin help simulation, how many steps?
I forgot.
It goes for 7100.
Yes. I don't know. Compare
That 17,000.
70,000. But you don't have to run it to the end. Or you can move to the next stage while it runs.
The image.
Yes.
We have to write the code to
Yes.
pass the image to the 3 profile.
Yes.
Based on the color. We assign.
So the idea is that we take an image, we turn it into grayscale, so it's black and white, right? Then we posterize it, which means we make discrete levels.
Okay.
So let's say if white is 0, black is 20, right? And then if it's sort of grayish, it's going to be 10. So each pixel will have a number between 0 and 20. And then what we do is that we take this, and for each, we go into each pixel and make the value is 10, we create 10 particles at that point.
Okay, I get it.
Right?
And other thing, we have reviewed the code of yesterday, and I noticed that you use some similar functions to analyze the H5 by
H5 file, yeah.
There are other functions to make the plot in 3D, because I try to understand what is the composition of a H5 archive, and it's like a chaos. There are many columns, and each column has subcolumns.
Yes.
And in the subcolumns there are the data.
Yes.
then if for 3D plots there are a function
So in SwiftMyo, there are a lot of functions that can directly make images out of the simulation. So if you go in the documentation of SwiftMyo, they'll give you different. Will tell you what are the different functions that exist that can be used.
HDF sí. Now we have a problem with the HDF.
Still?
In some computers only.
Yo no me acuerdo nunca.
Ah, hay una librería especial.
It's 17,000. Okay, so you're almost half.
I don't get the 10,000 yet. It's 9,100.
What?
9,100.
9,100. Okay, so more than half already.
Son dudas que o se le mete Sácame eso.
Y
activa el así. Pero está sin root.
Ah, y
Simplemente puedo dejar y esto no me lo roban.
And I think the plot was made only at the end, but I think the plot, there's a Python script here which plots the different snapshots. If you run it on the other snapshot, so it's the same thing.
mira, qué lindo.
Ah, es lo que estamos corriendo. Me falta la mitad todavía. Más 10,000. No, ni nada, robar. Están atrapando.
No, the HDF type only doesn't work. The developer, as soon as start the libraries,